The question of the ages. A question asked by tens, if not dozens, of photographers. Can you overfix film? Well, through the vigorous scientific testing funded by viewers just like yourself, the Shy Studios Research Education Training and Revolutionary Development School has indeed determined through intense research and assumption that yes, it is technically, maybe, probably possible to sorta kinda overfix your film, maybe. Now, should you be worried about accidentally overfixing your film? Probably not, but whether or not it is possible to actually overfix your film depends on a lot of factors: temperature, agitation, the film itself, and a bunch more. So make sure you watch the whole video because there are some very important variables which might answer the question for your specific setup. But in general, just don't really worry about it too much. Overfixing is probably not going to make a significant difference, and you'll see why. And remember, film development is a lot like cooking. There isn't necessarily a right or a wrong way to do certain things, but you probably don't want to eat chicken that's been seasoned with dish soap. First, for those who are new to film photography, and specifically film development, what even is fixing film? Well, to put it simply, when you develop film, only the parts of the film that have been exposed to light become developed with the developer chemical. The other parts that haven't been hit by light don't matter. The fixer removes those parts that have not been developed, leaving behind the actual negative image. It's pretty commonly known that it's a lot easier to underfix film than it is to overfix it. Typically, it's better just to be on the safe side and give your film a little bit extra time to fix than you'd actually need. However, if you read forum posts, you're always going to see people claiming that overfixing will cause bleaching or fading of the image. So I decided to test if that was true. To test the effects of overfixing film, I began by taking two identical photos, one right after the other. These were shot on a roll of Arista 100 EDU film, which is just Fomapan 100 sold under a different name. It's also sold as Lomography Earl Grey and probably other names too. I developed these as normal, with a fixing time of probably 15 minutes. I'm usually pretty lax with my fix times, so that could be plus or minus a few percent. I'm using Kodak Professional Fixer. This stuff allegedly has a capacity of somewhere between 67 and 100 sheets of 8x10 inch film. A single 8x10 inch piece of sheet film is exactly equivalent to a single 36 exposure roll of 35mm film, which is also the equivalent of a single roll of 120 film and 4x5 inch pieces of sheet film. Everything just kinda perfectly equals out. The fixer I'm using is likely significantly weaker than a fresh batch of fixer should be. I say this because even though I've fixed less than half the minimum roll capacity, and my fixer doesn't have any rotten egg smell at all, I have been using this exact same jug of fixer for over 3 years. According to the bag the fixer comes in, it should only have a shelf life of 2 months once mixed with water. So yeah, I'd say this fixer I'm using is not the strongest, but it still works perfectly fine. And I always do a test before I develop film anyway, just to make sure it still actually works. My clear times are usually only 2 or 3 minutes, so it's probably fine. The shelf life measurement on the bag probably takes into account a lot of factors that could degrade the fixer, factors which I clearly have not had. Anyway, here's the two photos from the initial development again. If I go back and forth, you can see they're both ever so slightly different, even though they were shot immediately, one right after the other, on a tripod with my wonderful Nikon G28-105 AF-D lens using the goofy wind-up clock self-timer thing on my Nikon FE. Maybe I stood in a slightly different angle for each shot, causing a slight difference in light, or maybe the light coming from the window changed ever so slightly. I don't know, but they're a little different. That doesn't matter though, because really I only needed the one shot. I only took the two just so I'd have one untouched negative and one I could completely destroy if needed. So to begin the experiment, I cut one of the copies off the strip of film. This single frame will become the experiment negative, and the other will be my scanner control. I then placed this single frame in a beaker, emulsion side up, and filled it up with fixer. I did this in my bathtub because I'm an idiot. I thought, this would give me a nice, well-lit space to work and film in, but it ended up being extremely uncomfortable and really cramped. I'm leaning over the side of the tub in a really awkward way, which caused me to splash a little fixer outside the beaker. Not a big deal. This tiny amount of unsaturated fixer can be washed down the drain without harming anything, especially since I took a bath after these tests, so that further dilutes the extremely minor contamination. So for test number 1, I left the negative in the fixer bath for 10 minutes. After the timer was up, I drained the fixer back into its jug, and then I washed the negative so that way there's no residual fixer left over. I hung it up to dry with clips on my little drying rope thing, which is normally strung across the ceiling if I'm developing a bunch of film. And after about 15 minutes of drying, it goes to the scanner and is scanned along with the control strip using Epson scan software in no color correction mode. This ensures that the scanner is not doing anything that could possibly manipulate the image. The files here are pretty much as close to raw data as this software can produce. I scan the control photo at the same time as the experiment to ensure the scanner is giving repeatable results, and I did this every time. That way, if I see the control image is significantly different than itself, then I know something must have went wrong during the scanning process. I ran 5 total passes of the experiment, so I had 6 scans of the control photo in total, and as you can see, they're all pretty much identical as expected, the only difference being minor misalignment and the specks of dust on the scanner bed are in slightly different locations. These control scans are just to prove that the scanner is functioning properly, so now they can be safely ignored for the rest of the video. The control shot is not going to be used for comparison purposes. Instead, the initial scan of the experiment negative before any additional fixing will be used as the actual control to compare the tests with. So as I said before, the first test consisted of 10 extra minutes of fix time. When compared to the initial scan, you can clearly see a slight change in how much light gets through the negative. If I measure this exposed area of dark shadow using the 31 by 31 average setting in my eyedropper tool, I get a value of 108 for the original scan and 110 for the first test scan. But this alone doesn't actually tell me anything, so I ran more tests, repeating the entire process of fixing, washing, drying, and scanning every single time. For test number 2, I fixed for 15 minutes, giving a total fix time of 25 minutes. Again, you can see a difference compared with the original, and also a slight difference when compared with test 1. The value of the shadow area in test 2 is 111. For test 3, I increased the fix time to 40 minutes, giving a total of over an hour of excess fixing. Again, compared to the original, it's slightly brighter, which actually means the photo is darker because we're looking at a negative. But if we compare test 3 to test 2, the difference is almost unnoticeable. Visually, I can hardly tell the difference between the two. In test 4, I increased the fixer time to 2 hours, and the results are almost identical. Again, this time I could certainly tell more of a difference between test 3 and 4 than I could 2 and 3, but still it's so minor that it's barely noticeable. The shadow measurement of test 4 is 113. So what does this tell me? Well, it could be that either this specific type of black and white film can't be overfixed using this type of fixer, or maybe my fixer is just so weak that it takes hours to actually fully fix the film. So for the last test, number 5, I left the negative in the fixer for not 1, but 2 whole days. That's 48 hours of fixing exactly, bringing the total final fix time to nearly 52 hours. Since the last test was so long, I would occasionally agitate the beaker if I remembered, which was actually stupid of me, and I'll explain why in a moment, but take a look at the results. Here's the original, and here's test 5. Clearly a significant difference. And when compared with test 4, again, a clear and noticeable difference. But was this difference due to the time of the test, or was it due to the fact that I would occasionally agitate the beaker during the test? The shadow area for test 5 is 119 compared to the original 108. If I plot these values of shadow measurement, you can see some sort of fall off is happening, but because I only did 5 tests, there isn't enough in-between data to see if it starts to linearly fade the negative or starts to roll off into nothing. And all these graphs and numbers are cool and all, but how does this translate into actual results of the photo? I'm only going to be using test 5 from now on since it shows the most extreme differences from the original. If I invert the image and do a basic value clamp using the original scan as my baseline, when compared you will clearly see the fixed test is darker. Yeah, big surprise. But did I actually lose any information? Instead of comparing both using one adjustment, I'll try to match test 5 to the original using its own adjustment curve. I had to do more than just a straight clamp on the level snivels like I did with the original. I also slightly brought up the middle on the curve to properly match the exposure, which also means I'm probably ever so slightly clipping the highlights in the test photo. But now you can see the test and the original are, for the most part, identical, though the test photo does seem like it has a lot of extra dust. Now that could be dust, but by this point, the test photo had been quite abused, so it could also be a product of overfixing. Look at this area of shadow under the candle holder thing in test 3. Now in test 4, you'll notice some new prominent dust spots have appeared. Looking at test 5, the same exact spots that appeared in test 4 are in their exact same locations. Now remember, between each test, I'm washing the film first before and after fixing, and you'd think that that would remove any stuck dust. Now these spots could be damage to the negative in some physical way, but clearly the spots from test 4 carried over to test 5. Either that's some really stuck on dust, some kind of damage, or it could have been caused by the fixer. This sort of agrees with Kodak's Motion Picture Film Processing Handbook, which says that fixer can form sulfur particles or other precipitates, so these dust-looking bits could very well be from overfixing or just not agitating the fixer enough, leading to deposits of some kind of particulate on the film. But besides that dusty-looking stuff, when looking at the two matched photos, Test 5, which had been fixed for 52 hours total, shows a very, very slight amount of crushed shadows and highlights. But it's so slight that unless you were doing a test like this, you would never even know. I'm actually reducing the contrast and brightening the image just so you can see the lost detail here. This is so slight that it could just be human error with the adjustment curve. It might not actually be real detail loss at all, and I doubt you'll even be able to see this on YouTube. Nothing else in the photo really appears to have lost any detail. And let me remind you, again, this is after 52 hours of extra fixing. That's over 2 days. But as we see from the scans, the photo did fade from the excess fixing. Or more specifically, the negative allowed more light to pass through it. Why does this happen? Well, I can't find a clear and straightforward answer. One possibility is that over time the metallic silver begins to oxidize, and that oxidized silver is then able to be brought into solution through similar reactions as fixing the film normally. The problem with that, though, is that the fading of the film is completely uniform across the entire image. Another more likely possibility is simply the film somehow is getting physically thinner, as in maybe the fixer, by some chemical process, is eating away at the film base. The fixer is sort of acidic after all, or maybe the fixer is somehow slowly removing the very slight color that the film base naturally has, since it isn't ever actually perfectly transparent. Both situations would allow more light to pass through the film and would occur at the same rate across the entire photo. This would also explain the fact that nearly no detail seems to be lost, because the actual silver on the negative isn't being affected. But no one really knows for sure what exactly is going on for real. I mean, I'm sure someone at Kodak in the 1930s figured this out, and there's a book in a building somewhere all about the intricate details of fixing and film, but it sure seems like it's settled then. You can't overfix your film. I mean, no one's gonna leave their film in a tank for 2 days straight, right? Well, not exactly. Again, remember, I'm using fixer that's like 20 times past its shelf life. Even though it still works to fix film, no problem, stronger solutions of fixer might significantly speed up the fading of film. And I'm sure there are plenty of you in the comments who have already typed out a 5-paragraph essay about how I'm so wrong, and that this next point, which I'm about to cover, is actually the real reason why my experiments did the things that they did. Don't worry. Even if you delete your comment now, I still got the email notification, and I will be laughing. So I'm using a fixer based on sodium thiosulfate. This is the traditional fixer chemical. But there is also something called rapid fixer, which is made from ammonium thiosulfate instead of sodium. Though I should point out my fixer actually has a form of ammonium added to it anyway. But what's the practical difference? Will rapid fixer actually affect the negatives significantly more than normal fixer? Well, I don't have any rapid fixer to test that isn't currently mixed with bleach, so if you want me to make a follow-up video doing these same experiments using rapid fixer, then leave a comment down below and I'll order some. Otherwise, for now, I still don't really have a clear answer to whether or not it's possible to overfix film using non-rapid fixer. Maybe certain film stocks are more susceptible to overfixing than the one that I'm using. And what about color film? So I decided to run a few more tests, this time using 3 sample frames of 3 completely different color films. The first being Ektar 100, then a frame from a roll of Cinestill 800T, which is actually just Kodak Vision 3 500T, and finally, I have a frame of unknown Eastman branded Kodak color film, probably from the late 70s. I really have no clue what this stuff is. It just has Eastman, H58X, F27X, and 73763 written on it, and there's probably other random numbers, but I don't know. It does have this little square thing, which might indicate it's from 1977, but this chart I'm using is for motion picture film, so that might not be accurate. I mean, you can clearly tell it's from the 70s. Just look at this kid from one of the other pictures. I'm pretty sure that this is just normal C41 film. It's just kind of old and yucky. For each of these, I chose a photo that wasn't really that important. The Vision 3 is an accidental double exposure. I bumped my shutter button against something, but I figured since I was pointing the camera down inside of a car, I could probably just double expose a real shot onto it, no problem, which did in fact work, but because I'm the CEO of Film Wasters Incorporated, the photo I took was of nothing. The Ektar 100 shot is just a boring brown photo. Like, what's the subject? The nasty tree that some deer nibbled on over the winter? It's a bad photo. Finally, the entire roll of this old mystery film is just kind of nasty and damaged. I recovered these from a non-temperature controlled, not very well weather-sealed storage facility where they were in decomposing, nasty, oily plastic covers inside of a cardboard box. I cleaned them up and rescanned them all, and there's some really cool shots on here and shows just how long film can last even in absolutely horrible conditions. This photo in particular isn't really anything special, and there's plenty of other good pictures of this glider, so I went with this one. I developed the Ektar and the Vision 3 myself. Both were fixed in a Blix bath, which is just bleach and fix mixed together, for about 6 minutes. The fix in my bath was using ammonium, aka rapid fixer. I have no idea how long the mystery roll was fixed for, but I can assume it was fixed during a normal C41 process, so the level of fixation of that film should be equivalent to my film. Instead of scanning a control each time, like I did with the black and white film, I'm just scanning the experiment because I really have no reason to believe that my scanner would give me skewed results in no color correction mode all of a sudden for no reason. This time, all 3 negatives went in the fix together, and I didn't agitate it at all. In fact, I couldn't agitate it at all because I had to meticulously balance each negative so it wasn't touching the sides of the beaker or any of the other negatives. I don't have a photo of this because by this point I was already pretty frustrated. For color film test 1, I let them all fix for 20 minutes. After it was done, I washed each thoroughly, and I noticed that it seems like color film takes much longer to dry than black and white film. And once dry, these newly fixed negatives had significantly more curl to them than before, and this continued throughout the entire test. It may be possible that overfixing causes extra film curl or warpage, but it could also just be that they were not held very straight while drying, or my bathroom's humidity was a little bit too low. The Vision 3 film in Test 1 was indistinguishable to the original. Absolutely no change occurred. This time I sampled the color values of the film base to compare each test. Test 1 was only 1 blue value higher than the previous. The red and green values remain the same, and this could simply just be a margin of error from the sampling point. The Ektar was a little different. The Test 1 scan was noticeably brighter than the original, but not by much. This time the film base color increased by 1 RGB value, but film base isn't the best measurement. It's better just to look at the whole photo, where you can see the total brightness is higher. Finally, the mystery film, which from now on I will refer to as the glider shot, had the most significant change in Test 1. Clearly, Test 1 is much brighter than the original. Again, this means more light is passing through the film, which will result in a darker image once inverted. The blue channel of the film base only went up by 1, but the red and green went up by 2 values. You can notice this in the history histogram, each channel moves to the right slightly. Now test 2, which lasted 2 hours and 10 minutes, putting the total fix time at 2.5 hours exactly. In test 2, the Vision 3 film actually showed a noticeable change, with a whopping 2 value red increase and 1 value increase for green and blue. Film base aside, you can now see the entire image is brighter. Well, I assume you can see it. I don't know how YouTube's gonna compress this, but works on my machine! The Ektar Test 2 also shows another slight increase in brightness, this time 3 red levels, 2 green and 1 blue. The glider shot, like before, shows the most noticeable amount of change, but the film base did not actually change as much as the Ektar did. Maybe that's sampling error, because you can clearly see it's a lot brighter. But so far it seems like color film is reacting more or less at similar rates as the black and white film did to excess fixing. But for test number 3, the final test, I again gave the film a lot more time. This test lasted 21.5 hours, which when combined with the previous total of 2.5 hours, brings the total cumulative fix time to exactly 24 hours. The changes for this test should be much more significant, and we see that as the case across the board. All 3 tests are much brighter than the previous, and significantly brighter than the original. Surprisingly, the glider photo actually had the least amount of change to the film base measurement, with only a 4 value increase in the red and a 1 value increase for green and blue. It was the Ektar shot that had the most amount of change, 10 red values, 5 green, and 2 blue. The Vision 3 was in the middle with an increase of 8 red, 5 green, and 2 blue. If you've been paying attention, you may have noticed something throughout these tests. The red channel is significantly more affected than the green and blue channels, no matter what kind of film. The red channel seems like it always increases far more rapidly than the others. Why is this happening? Well, this is another mystery I have some theories for, but I can't say for sure. And before I talk about those theories, I didn't even show you the inverted photos yet. I just used grain to pixel to convert each set of photos, and I also manually inverted them without any clipping or contrast adjustments just for some extra sanity checks. I will say immediately, I noticed when manually inverting, the fixed photos would have needed a lot more fixes to get them to be equivalent to the original if I were actually inverting them to create a nice looking photo. Grain to pixel, on the other hand, just made everything look acceptable automatically. The Vision 3 grain to pixel inversions look more or less identical. I think I prefer the overfixed version because the original has a slight green cast, but that could be adjusted easily. Otherwise, it sure seems like pretty much no details were lost. Even with my manual inversion, I see no apparent changes in the darkest shadow areas, though the overfixed negative does show some odd artifacts like this weird dark blotch, but that could be from dust or something, maybe? The Ektar shot is similar. The overfixed one has less watermarks than the original, which is pretty funny, but you can see an overall slight loss of brightness. Looking at my manual inversion, you can see the ever so slightest reduction in shadow detail underneath this rock. The overfixed shot seems to have lost some information, just barely though. This is just like the black and white test. Remember, this Ektar film was actually the most affected of the 3 by this test. Another interesting artifact of overfixing is the apparent reduction of red chromatic aberrations. Look at the right edges of the trees in this area of the original, and now the overfixed one. It's as if the red aberrations have disappeared. Well, it is actually still there, but it's hardly noticeable now. And this, I guess, is simply because there's more cyan overall in the image, which counteracts the red chromatic aberration. Finally, the glider shot, which really isn't the greatest photo to begin with. It was already nasty and damaged, but the overfixing actually seems to have removed some of the gunk off the film, but then created its own weird artifacts. The main important thing here, though, is the loss of color tonality. Looking at the wing of the glider here, we can see 3 colored stripes, but in the overfixed photo, these stripes are more noisy and the blue stripe has mostly vanished. Now this is actually because grain to pixel. When looking at the manual inversion, the blue stripe remains, but because there's more cyan in the overfixed shot, you would probably end up with similar results to grain to pixel after adding contrast and removing color casts. So to answer the question, can you overfix film? Yes, but should you ever be worried about it? Probably not. Now maybe I'll run this test again with Rapid Fix to see if Rapid Fix will degrade a negative at a faster rate, but I'm not sure if that'll actually happen, since still, I'm not sure why it happens. Why does the film fade? Why is the red channel more affected by overfixing than the others? The red sensitive layer of the film is probably the most protected layer. It has the green and blue layers in front of it, and behind it there's the film base. So you would think if we actually saw a layer dependent shift, it would occur in the other direction, right? Like with black and white, one possible explanation that makes sense is that the film base itself is just thinning or losing its color. After all, the film base is sorta kinda orangish, meaning if it fades, then more red light is able to make it through. But another possibility is that the color dyes themselves are physically changing, and for whatever reason, the red dye in particular is specifically susceptible to overfixing. I used the same exact fixer in both tests, and this fixer is specifically for black and white film. Now, the actual chemical that fixes film for both black and white and color film is the same chemical, but the mixtures you buy usually are not. Black and white fixer is usually somewhat more acidic than color film fixer. This is because manufacturers assume that people might be going straight from the developer to the fixer without a stop bath or a wash when they're developing black and white. So they make sure that the fixer is a little bit more acidic to neutralize any possible leftover developer that might be on the film. Whereas in color film, apparently the pH of the fixer can affect dye stability, whatever that means. This could be another experiment in the future, trying different levels of fixer acidity and seeing if the actual developed dyes change at all. I'm not sure anyone's ever done this because I've never seen any actual examples of this happening. Dye stability is something you see a lot of people online talk about to try to make you think you're going to ruin your photos if you don't buy the special magic color fixer, but they never actually provide a source for this information or explain how it can happen. I myself thought it was nonsense, but I was actually able to find one single mention of this in a footnote in the official Kodak Motion Picture Film Processing Handbook, Module 7. It says, the fixer pH should never be allowed to fall below 5.5, since low fixer pH affects the dye stability of Kodak color negative films. Well, there you have it. Don't use black and white fixer with color or it will make the dye less stable? Yeah, it's still vague and doesn't really say anything, but if you're really paranoid, adjusting the pH is really easy. Kodak says you can raise the pH using ammonium hydroxide, which is just liquid ammonia solution that's sold for cleaning stuff everywhere. But I'd assume you can also just use baking soda or even just dilute the fixer with more water, which should also raise the pH. Kodak spec says a fresh batch of motion picture fixer should be at a pH of 6.5. The safety data sheet for the liquid C41 rapid fixer that Kodak sells says the pH is 6.2, so this is all in close agreement. My fixer's data sheet says the pH when freshly mixed should be about 4.2 to 4.6, but I went and tested it and it seems like mine is at about exactly 5, maybe slightly less. I guess that's just minor exhaustion and dilution from using it for years. But still, my fixer is more acidic than it should be for color film, but not by much. And I don't think this would actually do anything because really the dye instability thing is probably only an issue during the initial fix. I think it's unlikely that just the acidity alone would significantly affect just the red channel's cyan dyes, but maybe it is. Or maybe all the effects seen here are simply because the fixer is slightly acidic. Could it be that you actually can't overfix your film, but over time, because the fixer's a little acidic, it'll just start eating away your film? I don't know, and I don't know if anybody knows. And if you think you know, then let me know that you think you know by writing a comment down below. And also, feel free to make suggestions for future tests that I could do. If you want to help me be able to continue making videos like this, consider becoming a channel member or donating to Shy Studios on one of the various sites I'm on, like Ko-Fi, and also buy the merch. But for now, that's it, and I'll be back next week with another video about something, maybe, hopefully.